Okay, well, 25 gigagrams, right? That would be a huge thing, all right? So 25 gigagrams, all right? 1 gigagram is in how many grams, right? Because I put the capital G, lowercase g on the bottom because I need them to cancel. So when you look at giga, go all the way across there, what you got? 10 to the what? 9. To the 9. All right. So 25 times 1 times 10 to the 9 is what? 2.5 times 10 to the 10th grams. Is anybody in the classroom did not get that? And if not, do not be embarrassed. All right, yeah.
I have that, but I have a question.
Yeah.
If we don't put the gigagrams, the little g or the L behind our exponent, would we be marked for that? No, sometimes you just write the problem, you don't put the G behind it, the unit behind it.
Yeah, no, that's not good. Every number needs to have a unit. Yeah. Yeah, in chemistry, most of the time, you have a number and a unit. All right. So yeah, that's important. And that is something you could get counted, it would get counted off for because, you know, I mean, that's just the way it goes. All right. Yeah. Yeah, 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 and that's another thing too. I mean, that's why I grade my tests. There cannot be a student assistant grade my non-multiple choice test, right? Which my tests are not multiple choice, because there's numerous ways to work the problem and numerous little things you can get, right? Like she could just put an E up and this and that, and you have to be able to go back and forth and say, okay, yeah, that's normal. You just can't violate math or physics, right? And other than that, you're fine. So 52 liters, and I'm going to build my shell and put the L on the bottom and the femtoliter on the top. All right, again, femto is a small quantity, like protein chemist or something along these lines. Now, I'm going to put a 1 here with this prefix just because that's the way it always goes. I'm going to the table and I'm going to search for a number that goes here, and that number is what? Negative what? Negative 15. Negative 15 liters. All right. So when you type in 52 divided by 1 times 10 to the negative 15, what you get? 5.2 times 10 to the 16? All right, now that's where you got the 16 from. I'm with you now. Femtoliters. All right. Anybody not get that? Okay, well now what we want to do, of course these are level 1 problems. Let's crank it up a level. There's about 6 levels of problems in this chapter 2. So a level 2 type problem would be going from something like a gigagram to a nanogram, let's just say. So now what's the difference in every single problem that we've worked up to this point and this one here? The difference is these problems are going to require 2 steps to get you where you need to go. All right? Because what you're going to have to do is you're going to have to go from a prefix to a base to a prefix. Just like that. So it's 2 steps. All right? Nothing's new, by the way. It's just 2 steps. All right, later on we'll have problems 5, 6, 7 steps. Nothing will be new. It's just multi-step. So here we're going to start out with 25 gigagrams. All right. Now a gigagram goes here and a gram goes here. So what is the number next to giga? We just got through working it. It is what? 10 to the 9th, right? 1 times 10 to the 9th grams. Now you guys are asking me, do I have to have this table on page 23 memorized? The answer is yes, you do. All right, the table on page 23 before the exam needs to be memorized. All right. Now, I've got another step here. I've got to go out now from grams. See, we started out in gigagrams, and now we're in grams. Now we got to go where? To nanograms. So how am I going to do that? What am I going to put in the top and the bottom as far as units go? Grams in the bottom and nanograms on the top. All right. 1 nanogram. Now that is what? 1 times 10 to the what? Negative 9. Okay. Now again, today, no problem. You're using your book. You have this wonderful cheat sheet and that. But by next Thursday, you know, you're going to have it memorized on the test. All right. What are we going to do? 25 times 1 times 10 to the 9th. Divided by 1 times 10 to the negative 9th for a total of an error. Okay, what have I done wrong here? 25 times 1 times 10 to the 9th divided by 1 times 10 to the negative 9th. There we go. 2.5 times 10 to the 19th. Nanograms. Okay? So I know it's having a hard time seeing this Elmo here. But it's 25 times 1 times 10 to the negative 9th divided by 1 times 10 to the negative 9th. You know, anytime you're working these multiplication and division problems, it's got a property called the distributive property. What that means is it does not matter the order you multiply and divide in any problem, as long as there's not other things going on, like addition, subtraction, square root, natural logs, you know, all that stuff rules change. But here, you only got two things happening, multiply and divide. So you type it in any order, do anything you want, and hit the equal button one time. Now sometimes students will prefer to take 25 times 1 times 10 to the 9th times 1 equals, and then take 1 times 1 times 10 to the 9th equals, and then divide the two numbers. Does that make sense? So anything you want to do is fine as long as you're getting the right answer. All right? So that's a double stepper. Let's see if we can do another one here. Let's try 37, and let's go from what? Milliliters to, give me a unit. Deciliters, DL. You want to do that one? Okay. So go ahead and give that one a go.